Okay, so in this confidence interval, we're looking again at proportions. We have a situation where we have truckers that typically keep logbooks in their runs, and according to various state and federal laws, they can only drive so many hours in a particular day. So in this case, the state police have set up a truck inspection station to inspect driver logbooks to see if the truck driver has driven too many hours. Well, in this particular sampling or study, they found 49 out of 348 truck drivers guilty of exceeding the allowable hours per day. So in this case, we want to see how good this particular sample is. And based on the results of the inspection station, we want to construct and interpret a 95% confidence interval for the proportion of truck drivers that have driven too many hours in a day. Once we've done that, then we'll briefly explain the meaning of a 95% confidence interval. Okay, so here the first thing that we want to do is again, this is a proportion. So the first thing we want to do is calculate that proportion. We found 49 of 348 truck drivers were cited. So we calculate 49 divided by 348, and we get about 14%, or 0.4, were issues citations. And so that leaves basically 0.86 that were not cited, or 86%. So the first thing we want to always do is check the conditions. First condition is the independence. And we want to make sure that we can assume that one truck driver's driving is not influencing another truck driver. Okay, so secondly, we want to take a look at the randomization condition. And we want to assume that all of the trucks are, assume all of the trucks are stopped randomly. Okay, next we want to look at the 10% condition. In that case, we know that 348 trucks are less than 10% of all trucks, actually truck drivers. So finally, we want to look at the success failure condition. And we want to calculate again, NP hat is equal to 348 drivers times 0.14. Again, that's 49, which is greater than or equal to 10. And we also want to look at NQ hat, and that's 348 times 0.86 is equal to 299. And that's also greater than or equal to 10. Okay, so all of our conditions work out, so we're in good shape, and we can begin constructing our confidence interval. So this is going to be a 1 proportion confidence Z interval. And we know that N is equal to 348, and P hat we've already solved equal to 0.14. So then our standard error of P hat, of course, is equal to the square root of P hat Q hat divided by N. So we take the square root of 0.14 times 0.86 divided by our 348 samples, and that equals 0.0186. Okay, so for a 95% confidence interval, we know that Z star then, or the critical value, is equal to 1.96. So now we see that our margin of error is equal to Z star times the standard error of p hat, which is equal to 1.96 times 0.0186, which is equal to 0.03365. Okay, so now then our 95% confidence interval is then 0.14, which is again our proportion, and we're assuming that proportion is the mean or the average, plus or minus the margin of error, 0.0365. Or we can also state that as if we add and subtract the margin of error from the mean, we get 0.1035 and 0.1765. So we're confident, we're 95% confident that between 10.4 and 17.5% of truck drivers have driven too many hours in a day. Okay, so that's basically what our confidence interval means. So now if we look at the meaning of a 95% confidence interval, we can say that if we repeated the sampling and created confidence intervals for each of them, 95% of the confidence intervals would contain the actual proportion of truck drivers that have driven too many hours in a day. So let's repeat that. If we repeated the sampling and created confidence intervals for each of them, 95% of the confidence intervals would contain the actual proportion of truck drivers that have driven too many hours in a day. Okay, so the important thing about this is we have a situation where we've taken basically a random sample, and we find that we can establish a proportion with that random sample of drivers that are exceeding the legal requirement for driving hours. We take that data, we establish the standard error for that data with SC of p hat of 0.086. We know the proportion was 0.14 citations, so we can derive a confidence interval by calculating the margin of error, that is for 95% confidence interval. Again, that Z number is 1.96, or Z star, the critical value, and then calculate the margin of error, 0.0365, and then construct our confidence interval, 0.14 plus or minus the 0.0365, and then we have our confidence interval. Now, we don't know exactly what the true proportion is going to be, but we know that it's going to lie, we're 95% confident that it's going to lie between 0.103 and 0.176, or 10 to 17% of all drivers.